Good morning, guys. Today we'll be revising foundation engineering, and foundation engineering may will be specifically dealing with the shallow versus deep foundation, its classification, isolated footing, combined footing, strip footing, strap footing, and raft footing. Also, we'll see the terms associated with bearing capacity, that is gross pressure intensity, net pressure intensity, ultimate bearing capacity, net ultimate bearing capacity, then there is gross safe bearing capacity, etc. etc. We'll also have some PYQs based on the type of footings, the definition which are characteristic to each footing. Now, first of all, if you see that सॉइल फाउंडेशन का फेलियर दो क्राइटेरियाज में डिफाइंड है. वन इज़ द सेटलमेंट ऑफ द सॉइल एंड द सेकेंड वन इज़ द शेयर फेलियर. इन सेटलमेंट ऑफ सॉइल इट इज़ सेड दैट एक गिवन सेटलमेंट की रेंज तक अगर फाउंडेशन सेटल करती है देन इट इज़ फाइन, एल्स it will be considered as failure in settlement. And similarly we have shear failure, और shear failure broadly classify होता है थ्री टाइप्स में, that is general shear failure, local shear failure and punching shear failure. इन तीनों की characteristics next video में will be covering. Each shear failure has its own graph of stress versus strain, अपनी peculiar characteristics हैं इन तीनों shear failures की. One thing we can remember is that settlement criteria is more dominant in sands because वहाँ पर settlement जल्दी हो जाती है, whereas in clays the shear criteria is more dominant. So now फाउंडेशन की जो बेयरिंग कैपेसिटी है उसको निकालने के दो अप्रोचेज हैं. वन इज़ द एनालिटिकल मेथड for which we have theories such as Tarzagi's bearing capacity theory, we have some Skempton's theory, we have Mayrhof, and then there is IS code method also, which is actually a modification of Mayrhof only. You know the formula CNC plus QNQ plus 0.5 B gamma N gamma, that comes in Tarzagi. Now there are field methods also, that is plate load test, then we have standard penetration test, then we have cone penetration test. We'll also see it again in the next video. Now let's classify the foundation. So you see, generally we'll be discussing in respect to a square footing. So if the depth to the width ratio of any foundation is less than equals to 1, as per Tarzagi it will be considered as a shallow foundation, that is, which is not very deep. The purpose of the foundation is simple: to transfer the load that comes from the superstructure via the columns to the soil layer beneath it. Okay, and as per the Skempton, this same ratio, where in Tarzagi it was less than 1, for Skempton it comes out to be less than 2.5. We also have to see that for the shallow foundation, the primary source of stress transfer is through the base resistance or the end bearing, whereas for deep foundation such as your piles, the not only the base of the footing but also the side face or the side surface also contributes in the transfer of stresses. Hence, for shallow foundation we have due to base resistance, for deep foundation we have side plus base resistance or skin resistance both. Now we can classify the shallow foundation into two parts. One is the footing and the other one is the raft or the mat foundation. For footing we have isolated, where we'll have one column per footing, एक कॉलम के लिए एक ही फुटिंग देते हैं हम. Then we have a combined footing where we have more than one column having one footing beneath it. Then we have strip footing, usually given for bearing walls, where the length is very much greater than the width. Then we have the strap footing, which is a sort of combined footing where a strap beam is attached, and then we have a spread footing like this. And then we have a raft or mat footing. We'll be discussing about it. In the deep, we have deep foundation, we have piles, we have well or Kaizen foundation, we have deep footing. There's another criteria which says that if the ratio of depth to width of the footing, if it comes in the range of 1 is to 1 and 15, it comes out to be moderately deep foundation, and if it is greater than 15, it will be considered as a very deep foundation. Now in strip footing, this is a diagram which very well shows you how the length of this footing is much greater than the width. Hence, it has also been asked in one question, if length of the footing to the width of the footing, if this ratio goes greater than or equals to 2, it becomes strip footing. It is usually given for load bearing walls or closed column rows. And very much important point which has been asked in the question, you give strip footing not where the subsoil has a bad bearing capacity, rather where it has a good bearing capacity. तो हम इसे वहाँ नहीं देंगे जहाँ पे कि हमारी soil की bearing capacity कम है. Similarly, we have got strap footing, and what strap footing does, it joins two footings, footing number 1 and footing 2, with a strap beam. You can see the strap beam here. And this strap beam is not designed to share the load. Yes, it doesn't, share the load of the building. It is not having any load. It is also considered as weightless because it does not, has a contact with the ground or the soil. Let us see this question. It says the correct statement about the strip footing. So, strip foundations are designed for structure where the load is relatively low. We have to check out the correct statement. No. Strip foundations are not designed where the load is relatively low. Rather, because the load is more, we transfer it like a line load. It says that it unevenly transfers structure loading at found. No. Any structure which is either continuously in line or has a large area will transfer the load very uniformly. Then it says that they are generally used for ground where the subsoil is of good bearing capacity. Yes, you will only give strip footing if the soil has a good bearing capacity, and if it doesn't have a good bearing capacity, we will not go with the strip footing. We might have to shift towards other options like raft or mat or even deep foundation where the load is very high. Then comes, they are generally used where the ground where subsoil is of low bearing capacity. As I said, no. If the ground has low bearing capacity, we will not use the strip footing. Then comes the points. What are the choices for a particular type of the footing? Of course, magnitude of the load. If the load is low, we might go with, like generally it is found in our residential buildings, we will go with isolated footing. And if the nature of how the nature of the subsoil strata, of course, it is loose or it is dense, has a low bearing capacity or not, all matters, because that will decide whether we will have to go for deep foundation or it's okay to with the shallow foundation. And then the nature of superstructure, of course, the amount of load that is coming through the superstructures matters. Then it says functional criteria like erosion of the presence of plant roots. Yes, if a soil is prone to erosion, like we see that loose saturated soil में liquefaction होता है, then we have to look at that also. Now we have a short single summary of each footing, its definition. If you have spread footing, which is like this, then it is done to support the individual columns. If we have strap footing, where a strap beam is given to join the two, it connects two individual columns which behave as a single unit. It is used when the distance between the two columns is very large. Then comes combined footing, when two individual columns are so close that you have to overlap. If I have these two columns, then I will, instead of giving individual footing for each, will give a combined footing. Then comes strip footing. It is a type of spread footing or continuous footing, which in which number of the footings provided are in a single line. It is like a strip only, mostly used for load bearing walls, and in the case where bearing capacity is good. Again, it is an important point, bearing capacity is good. Then is mat or the raft footing, when there is suspicion of differential settlement, or when all the columns in a given area are so close, then this footing is adopted. Usually multi-story buildings have the raft footing. Then the second question comes, which type of footing is most commonly used when a column is placed near a property boundary, restricting footing extension on the one side? Of course, अगर आपके पास property restriction hai, you don't have much area, then you cannot give mat footing. You also won't give isolated footing, you will go for strap footing. So as it says that strap footing is used when the column is close to property line and its footing cannot be extended symmetrically on one side. It connects eccentrically loaded footing to an interior footing using a strap beam, allowing the load to be distributed evenly or avoiding tilting. So again we have the definition of these footings. Isolated footing is one which supports a single column. It could be of shape of a square, rectangular or circular. It is used when the columns are well spaced and the loads are also moderate. Limitation is that it is not suitable near the properties lines. If this is the let's say plot of yours and this is somebody else's plot, and if this is his foundation, you cannot think of giving your foundation in somebody's else plot. Hence we go for combined footing, and strip footing is sort of, you can say, a subtype of combined footing. So useful when isolated footings would overlap. Then there is mat footing or raft foundation, when a large continuous slab supporting multiple columns or an entire structure, where it is given when the soil bearing capacity is low. And when it is given when the loads are heavy, because as I said, not just the type of soil beneath, but also the load also matters before deciding what sort of footing or foundation we will give. The advantage is that it distributes load evenly over a large area. Limitation is that it is expensive, so we will not typically be use where we are having boundary restrictions, or when the load is not heavy, load is light. Then it says, which of the following statement about the strap footing? As I said, strap footing does what? It joins two footings. It says it is weightless. Yes, it is considered weightless. The soil pressure is uniform beneath few individuals. The second point says that interior footing is centrally loaded. Yes, the interior footing is centrally loaded. Then it says the strap is rigid, perfectly rigid. Yes, it is one of its assumptions. It says the soil pressure is uniform beneath few. This is where it is wrong. Instead of few, soil pressure is uniform in all the individual footings. So yes, let us see. A strap footing is a type of combined footing which consists of two or more column footings connected by a concrete beam. In other words, when the independent footing of two columns are connected by a beam, it is called strap footing. That is, it is a subtype of a combined footing where two or more column footings can be connected through a beam. This type of beam is called strap beam. It is used to distribute the weight of either heavily or eccentrically loaded column. As I said, let us say you were forced to have your foundation being loaded like this, so it does create some eccentricity. It is not centrally loaded, so to prevent it, we provide the strap beam and adjust it with another footing or column to distribute the load uniformly. It says that the strap beam does not remain in contact with the soil and thus does not transfer any pressure to the soil. The strap, assume, is infinitely stiff and serves to transfer the column load on the soil with equal and uniform pressure under both the footings or all the footings. These are the types of strap footing. Here it is a strap beam, here it is a strap beam. You see these two strap beams, एक ऊपर है एक थोड़ा नीचे है. This could also happen. Both of them are at the same level. This is usually given when one is heavily loaded or has much more load with along with eccentricity. Hence we increase the area of this strap beam here, ताकि वो उस इसेंट्री से ओवरटर्न करने की सिचुएशन में ना रहे. ये इनका प्लान है. यू कैन सी ये ऐसा वाला केस वहीं रहा होगा जहाँ पर आपकी प्रॉपर्टी की बाउंड्री ख़त्म हो चुकी है एंड यू कुड नॉट यू आइडियली आपको ऐसे पूरी तरह देना चाहिए था, बट you could not give it here due to the property dispute. When you will see a property dispute, you will go with the strap footing also. Now there are applications. Strap footing is oftenly used in conjunction with columns that are located along building property. Typically columns are centered on column footings, but in condition जहाँ पे कि columns are located directly adjacent to the property line, the column footings may be offset so that they do not encroach the adjacent property. Hence eccentric loading होने के chances रहते हैं जिससे कि tilting हो सकती है. So strap beams restrain करती हैं उनकी overturning की tendency को by connecting it to the nearby footing. The second point is it is also used when the distance between the column is so great that a combined trapezoidal footing having high bending moments. In this case, column is provided with its independent footing and a beam is used to connect the two footings. It says that the phrase weightless is frequently used to describe strap beam because while it does sustain the weight of the load, the beam itself has no weight in the sense that it adds no extra load on the structure. This is because the force exerted on the beam from the support balances the weight. Now we have matched the following. Let us see. When the columns are very close to the property line, this question is somewhat disputable because I remember when the columns are very close to the property line, it should have gone with third strap footing, but since strap footing in itself is a subtype of combined footing, it has given the answer to be as when the columns very close, it has given as combined footing. Let's just see. The two transfer the moment between two adjacent footings. It is also one of the criteria to transfer the moment. We can go with strap footing, and then it says to restrict settlement of the soft clays or silts, we go with floating or balancing rafts. And then it says to restrict the damages due to volume changes or swelling, we go with the under reamped piles. So D is 2, that is for sure. C is 1, that is for sure. We see no other option with D2 and C1, hence we are bound to go with B goes with 3 and A goes with 4. Ideally, I believe it should have been A3, B4, C1 and D2. But since they have not given any such option where 3, 4, 1, 2 comes, hence we will be bound to be going with third. You see, strap footing is a type of combined footing. It consists of two or more columns connected by a concrete beam, and we have a strap beam. It's used to distribute the weight of either heavily or eccentrically loaded column footing to the adjacent footing. It is used to transfer the moment between two adjacent footings. Under reamped piles are used where the soil has a tendency of swelling. Then there is floating or balancing raft. It is to balance the weight of the removed soil with the structure of the same weight. What happens in floating raft or balancing raft is that we simply remove a section of soil, let's say up to H, और उस रिमूव की हुई सॉइल का जितना भी वेट होता है हम उतना ही वेट का स्ट्रक्चर उस पर लोड कर देते हैं, ताकि उसमें कोई भी, जैसा भी हमने कंसोलिडेशन में देखा है कि जितना उसमें स्ट्रेस पहले लग रहा था उस सॉइल की वजह से, सॉइल सरचार्ज की वजह से, उतना ही उस स्ट्रक्चर से लगेगा. तो सो देयर विल बी नो सेटलमेंट. तो ये वहाँ पर दिया जाता है जहाँ पे सेटलमेंट का हमें खतरा हो, क्योंकि सॉइल पे जितना लोड पहले लग रहा था सॉइल के होने से उतना ही बाद में भी लग रहा है, तो कोई सेटलमेंट का चांस नहीं होगा. Then comes combined footing. Combined footing is also given where the property is close to the property line. Then comes another question. So of course, isolated footing will go with individual column. That is, D will go with third. We have two options with D third. Pile foundation will give for, let us see, mat foundation. Mat foundation will go with for supporting all columns of the structure. So B will go with 4. B is 4 in this and B is 4 in this. Then we have A. Combined footing is for 2 or more columns, that is for sure. So A should go with 1. B should go with 4. C for isolated or group of columns, and D isolated footing will go for individual. Let's see the answer. For isolated or group of columns, that is, C will go with third. Sorry. Yeah, C is going with third. Yes, I believe the options are not correct in this question, because it should go like this. Combined footing will go for 2 or more columns. Mat will go for supporting all the columns of the structure. Isolated will go with third, and pile will go for isolated or group of columns. So combined, A will have A will go with 1, B will go with 4, C will go with 2, and D will go with 3. Yeah, sorry, second is the correct answer, my bad. As you can see, isolated is for individual column, pile is for isolated or groups of columns. When the strength of the soil layer is very low or less and the incoming load is very high, then pile is given, pile foundation is adopted. It goes deep into the ground and transfers the load to strong solid strata. It is also used to increase the load bearing capacity of soil by installing a group of piles, because the screen friction provided in the piles enhances the bearing capacity of the soil. So raft foundation is also used to reduce the settlement. It is used where the bearing pressure is very low, allowable bearing pressure is very low in highly compressible soil, by making the weight equal to the soil excavated. For unequal loading also we give combined footing. Then we have the settlement for different types of foundation, where for a raft foundation we have 65 to 100, for sandy we have 40 to 65, for the maximum differential settlement for clay is 40, and for the sandy is 25. Actually, I believe this question is from RCC rather than Geotech. I believe, because these values are often asked. What is the maximum differential settlement in clay soils? It is 40 mm. What is the maximum differential settlement in the sandy soils? It is 25 mm. It is asked in RCC often. Let's see another question. There are two questions. The trapezoidal combined footing I required when you have a space outside the exterior column limited. Of course, you see combined footing वहाँ पे दी जाती है, just like strap footing, जहाँ पर limitation होता है space का near the property boundaries, or when the exterior column is heavier. Whenever we have one column which is having a more load and one is less, we provide trapezoidal. जिसका लोड ज़्यादा होता है उसे ज़्यादा एरिया दिया जाता है, और जिसका लोड कम होता है उसके कंपैरेटिवली कम एरिया दिया जाता है. So both are correct, hence both 1 and 2. Then we have raft foundation is useful where soil having low bearing capacity, it is correct. Heavy loads are transferred, it is correct. When a soil is when the superstructure is sensitive to differential statement, yes, raft foundations make sure that differential settlement doesn't happen. So all of these. So soil is given when the soil pressure is low, building loads are heavy. They are used where the soil mass contains compressible layers of soil and is sufficiently, so the differential settlement is difficult to control. Then it is this question is rather, I'd say, data based. It says the permissible differential settlement and the limiting maximum settlement for a clay. We just learned it above that the maximum differential settlement for a clay is 40 mm. So D is 40 mm for sure, and the maximum limiting settlement for the clays is 65 to 100. So third option is correct. As it said, the allowable settlement depends on the many of factors, including the following: type of the construction, use of the structure, sensitive finishes. What IS code recommends in terms of maximum permissible settlement for clay, it is 65 to 100, and whereas for a raft footing on the sand is 40 to 65. Now you see, this is also important. If it is a isolated footing, these are simple values, which is 65 mm for clay, and one could see that the concept is that the rate of the settlement in a sand is much higher. It settles very much quickly, but if we see the final settlement, then the clays would be having a slow rate of settlement, but the amount of settlement they will have will be much more than what sand happens. In sand the settlement happens quickly, in clay it happens slowly, but the total amount of the settlement will be much more than what is in the sand. So for raft we have a range. We have to keep this in mind, that be it isolated or be it raft, the amount of settlement in clay will be more than that in the sand. This question is also asked sometimes. The permissible angular settlement for high frame structure, it should be less than 1 by 500, and to prevent any type of minor damage, it should be less than 1 by 1000. Then there is a note that it says for multi-storied building having isolated foundation on the sand, the maximum permissible settlement is 60 mm. Then comes a raft foundation is preferred over isolated footing when the soil bearing capacity is high. No. Low में किया जाता है. Loads are very small. No. Soil is weak and different settlement is expected. Yes, that is the correct answer. Yeah, if it is weak soil, differential settlement is expected. High loads, soft pockets. Then comes another question which says, during design of the raft foundation according to the IS code, the maximum settlement in the sand and hard clay for RCC structure. For this question the answer is 75 mm. It says that for an isolated foundation on clay soil, maximum settlement is 75 mm as per IS 1904, and for sands and hard clay it is only 50 mm. For raft it is limited to 75 mm. Which of the following types of foundation is most suitable for structure with heavy vertical loads such as high-rise buildings and industrial? Of course, we'll go with pile foundation in this case. So it is a deep foundation. It is most suitable for high-rise building and industrial structures. Then comes to calculate the minimum depth of a shallow foundation using Rankine's formula. You see, we know that the Rankine formula is Q equals H by gamma 1 minus sine phi upon 1 plus sine phi, and what they have given us is the pressure and the angle of repose. So let's see the answer. We have the Rankine formula where Q is the pressure, net pressure or gross pressure, Gamma is the unit weight, and using the formula 1 minus sine phi by 1 plus sine phi, all the values are given here. We can find out the depth of the foundation. Now there are certain guidelines for selection of foundation. If the structural load is less and the soil is medium to dense, then we will go for a shallow foundation, that is isolated or a strip footing. If the structural load is heavy and the soil is loose or weak, since the load is heavy, we'll go with raft or deep foundation. If the swelling pressure is high, or if the swelling potential is high and the differential free swell value is more than 35% and the free swell value is greater than 19%, we'll go with raft or deep foundation. If the footing area is 40% more than the plinth area, then we'll go with the raft foundation or combined foundation. And if the structural load is very heavy and the soil is medium to loose, we'll either go with pile foundation or in combination of raft plus pile when the load is very heavy. If the structural load is heavy and the foundation is to be placed in running water, we'll go with well foundation or compaction pile. Well foundation is given in Taj Mahal also, I believe. If the soil is loose saturated sand and it is prone to liquefaction, we will go with compaction pile. This one is important. If the structural load is less, that is if it is 1 to 3 buildings, we can go with isolated footings. If the soil is expansive and high swelling and shrinkage characteristics that often seen in black cotton soil, we will go with floating raft or balancing raft or under rimmed pile. Now comes that the minimum depth for footing as per IS code is 15 centimeter. Now comes the terms related to the bearing capacity. We'll see it. So, first one comes, that is gross pressure intensity. Gross pressure intensity is nothing but it is the pressure at the base of the footing due to the self weight of the footing, its own weight, the applied load that is coming from the superstructure, and the soil surcharge above it. And gross pressure may be greater, equal or smaller than the bearing capacity of soil, but for design, gross pressure should be less than the safe bearing capacity. In analysis, we often consider the unit weight of concrete to be nearly equal to the unit weight of the soil. So as you can see, this is your gross pressure. It is the load that is coming from the superstructure. This will be the stress and the overburden pressure by the soil above it. Then net pressure intensity is the part of the gross pressure at the base of the footing which is in excess to the initial effective overburden pressure. So if in this term we reduce the surcharge weight of the soil or the overburden pressure, we get the net pressure. So what do we account in the gross pressure? It is the load of the structure, it is the weight of the footing, and it is the weight of the soil above footing. If you remove the weight of the soil above footing from the gross pressure, then you give the net pressure on the footing. So Q1 is given by QG minus gamma dF. Then there is ultimate bearing capacity. It says if you keep on increasing the gross bearing pressure increase, and you reach a limit, the maximum at which there will be no failure, but just above that capacity, that pressure, the failure will occur, you are at the ultimate bearing capacity. So it says that the maximum gross pressure which can be applied on footing without any shear failure, or it is the minimum gross pressure at which the soil fails in the shear. So you keep increasing. Let's say the gross, the ultimate bearing capacity of the soil is 100 kilopascal. So you will keep on increasing, and exactly at the 100 kPa, the soil is on the verge of the failure. And just when you move 0.1 kilopascal above it, the soil will fail. So it is said to be the maximum, gross pressure without any shear failure, and it is also said as the minimum gross pressure at which the soil fails, because just before it your soil is safe, and just at it or above it your soil will fail in shear. Then comes net ultimate bearing capacity. Just we had the way we have gross pressure intensity minus gamma df equals to q net pressure intensity. Similarly, net ultimate pressure intensity is nothing but ultimate minus gamma df. Then there is net safe bearing capacity, which says it is the net pressure which can be applied safely at the base of the footing without any risk of shear failure. It is given by net ultimate bearing capacity divided by the factor of safety, and the factor of safety is usually taken as 2.5 to 3. Then we have safe bearing capacity. It is that gross pressure at the base of footing which can be applied safely without any risk of shear failure. So it is given by ns plus gamma df, that is net ultimate by factor of safety plus gamma df, and this is its formula. So if we have to calculate net safe load carrying capacity, we'll multiply the net safe ultimate bearing capacity times the area. Similarly, if we have to see the safe load carrying capacity, we'll simply multiply the safe bearing capacity times the area. So this is how it goes. You have the ultimate bearing capacity, you will subtract gamma df, and then you will get net ultimate. You will divide it by a factor of safety. You will get net safe bearing capacity. If you will add gamma df, you get safe bearing capacity. Then till now we had the shear criteria. Next we move on to the settlement criteria. In the settlement criteria, we have net safe settlement pressure, shown with QPS, or the safe bearing pressure. It says that it is the maximum net pressure which can be applied without any risk of settlement failure, or the pressure at which the settlement of the footing is equal to the permissible settlement given by the IS code. So the limit says it is 40 mm for sands, and you have reached where it will just be near about 40 mm or on the verge of 40 mm. So that pressure is your net safe settlement pressure or the safe bearing pressure. Then there is allowable bearing pressure, which says it is the net loading intensity at which neither the soil fails in shear nor is there an excessive settlement. So that means you will not fail in the shear criteria, and you will also not fail in the settlement criteria. So this is given by QA is given by minimum of the QPS, which we just discussed here, and the QNS, that is the net safe pressure, net safe bearing capacity. And then depending upon the pattern of the shearing zone, there are 3 types of failure which are observed, that is general shear failure, local shear failure, and punching shear failure, which we'll be discussing now in the next topic, in the next video.